This video delves into the fascinating world of emissions that cool the planet. We'll also look at the uncounted emissions and how some emissions are hidden by convention. Firstly, as we saw in the video on deforestation, IPCC conventions make it very hard to identify even the single greatest agricultural emission, deforestation. It's hidden in net accounting in the obscure category of land use change and forestry. So assembling all the farmed animal emissions requires some sleuthing. But from the latest IPCC assessment, let's look at the gases and how they contribute to global warming. This graphic from the IPCC's fifth assessment shows the temperature impact of each of the major greenhouse emissions. That's temperature, not global warming potentials. So this includes other factors such as how sensitive the climate is to warming from each gas. Above the line in the centre means we have warming, and below the line, cooling. Also note that the temperature impact lasts a lot longer than the gas. For example, the temperature impact of methane lasts for about 50 years, whereas the gas half-life is about 10 years. Firstly, let's look at carbon dioxide, the red line. See how it keeps warming beyond the 80 years of this timescale. About 3/4 of the carbon dioxide is from fossil fuels, 20% from deforestation, and about 8% from cement production. So warming from fossil fuels would be something like this. But the interesting point is that whenever we burn fossil fuels, particularly coal but also oil, we also emit sulfur dioxide, shown here in green. Sulfur dioxide is a short-lived emission, but it scatters sunlight and forms clouds, and it's strongly cooling. You can see that for the first 10 years or so, the sulfur dioxide from fossil fuel emissions gives more cooling than the heating from co-emitted carbon dioxide. But then, sulfur dioxide for that year is gone, and the CO2 keeps warming for centuries. But continuous sulfur dioxide emissions continue to mask warming from carbon dioxide. Remember, below the line is cooling and above the line is warming. So the net warming from fossil fuels is the warming from carbon dioxide minus the cooling from sulfur dioxide, which would look something like this. Fossil fuels also release nitrogen oxides, which are different to nitrous oxide, that also have a cooling impact over time, further reducing warming from carbon dioxide. We'll see later that these gases co-emitted with fossil fuel burning mask or reduce warming from carbon dioxide by about 30%. The next most important gas is methane, shown in brown. Note how methane's warming peaks after 10 years after the emission and then declines. See how for the first decade, methane causes more warming than carbon dioxide, particularly when we subtract sulfur dioxide's cooling. So methane is the most important warming agent for the first decade or two after the emission. Now, let's look at emissions from fires. We saw how the world is burning with deforestation fires and pasture maintenance fires, and some crop residue fires, with 80 to 90% of fire intentionally lit. Fires send up a cocktail of emissions, so let's go through them. The carbon dioxide released is not counted because it will be taken up with growth the following year. But there are several other emissions. First, black carbon, or soot, shown in black, is emitted mainly by open fires. Some black carbon comes from dirty diesel engines, not Europe or California with their strict rules, and some comes from cooking fires and wood-fired brick kilns, but mostly it's from agriculture. Black carbon starts warming right away, as you can see from the graph, and when it lands on ice or snow, it's extremely warming because it turns the snow reflector into a heat absorber. Fires also produce organic carbon, shown in darker blue here, and that causes cooling and balances out some of the warming effect of black carbon. You can tell by the colour of the smoke from the fire. If the smoke is dark, that will be warming, but if the smoke is white, it will cause cooling because it reflects the sun's rays. Fire also emits large amounts of carbon monoxide, which causes significant warming, shown in dark grey. In developed countries, most of the carbon monoxide is from vehicle emissions, but globally the main source is fire. By the way, neither sulfur dioxide, black carbon, organic carbon or carbon monoxide are counted in sector emissions, and that's by UN IPCC convention. They're just not counted, even though they have a significant impact. Ozone is another strong greenhouse gas not shown on this graph. It's not an emission, but mainly caused by the breakdown of methane in the atmosphere. But the point of all this is, firstly, for the first decade or more following fossil fuel emissions, the co-emitted sulfur dioxide actually causes more cooling than the carbon dioxide causes warming. And continuous sulfur dioxide emissions cause a continuous level of sulfur dioxide in the atmosphere, which masks carbon dioxide warming. Secondly, methane is the major cause of warming for 1 to 2 decades following the emission. And thirdly, fire emissions, mainly for grazing animals, are strongly warming but rarely included in any inventory as being caused by animal production. There is no mention of these emissions, for example, in the FAO reports.